All right, so the next thing we're going to do is look and see what's going on for the Beyond Lab. So I'm just going to show you just the NMR part of that so you know what to look for. So we're going to go in, let me share my screen. Okay, so here's the procedure, right? So I'll go ahead and open that. It's not at the top. And then we're going to look at Beyond Labs. Here it is. So you open it up. Make it a little bit smaller. Okay, so as it says, you're going to go into the experiment. The experiment's 9.1, and then the first thing we're actually going to do, let me get in there, carboxylic acid, ether formation, typo, right? And then we're going to take an NMR of the stuff first. So just like we did with the IR of the alcohol lab, we're going to take all the spectra that we need of the starting material, and that when you get to the end, you won't just have to magically know what it is. You'll be able to tell like that it's different from the starting material, and it gives you a chance comparing those things. So that's why we're doing that. So we're going to the lab. We're going to first do ethanol. So I'll get the ethanol here and drag it into here. And then it just says drag it down here and take the NMR. So I'm going to show you how to do it, but I don't want to do the ethanol because then you won't have anything to do. So I'll do the benzyl aldehyde. So I'm using a different compound, but it's the same process. So basically take whatever you want, put it in the flask, drag it down here, and then you're going to take the NMR. This right here is the NMR. It's right behind the IR. So just like for the IR, when you drag it over, it makes this little disc because those are salt plates. When you click on this, it should have a different icon. So it should be this long skinny tube. That's an NMR tube. So I'm going to click on this and drag it over and then let go. It's just like doing the IR, same process. And then this is the NMR that I got. So it's for a different compound. It's not for your compound. This one has a peak here and yours doesn't have that. So I would click it here. I would click save. Now, I just wanted to let you guys know like what information you need on this NMR. So first of all, you can look at the shifts by just looking at the numbers and just estimating based on where they are showing up. So like this one's right about at like 9.9, right? Then this one would be like around, looks like 7.4 or 5. So then you're just going to use the numbers at the bottom for the shift. Then for the integrations, they're actually listed down here. So if you look, this is called peak 1, 2, 3, 4. They just number them. Peak 1, this is not the height, it's the integration, is an integration of 7, and this one's 13. So if you look, those are probably not right. That's way too many hydrogens. So we're just going to take the ratio of this. So I just take the smaller one and then divide the bigger one by that smaller one, and I should get a whole number ratio. If for some reason you didn't, you could multiply by 2 if it was like a 3 or something, you've got 1.5. So if I take this one, divide it by this one, obviously 13 would be like 2 hydrogens, and then 7 whatever would be like 1 hydrogen. So it says peak 1 is going to be about 1 hydrogen because it's 7. This one's going to be about 2 hydrogens. Peak 3 is back to the same as the first one, so that's going to be about 1. That's this one right here. And then peak 4 is going to be, it's a little bit higher than that one, but it's about 2, right? It's definitely not 3. So that's going to be a ratio of 1 to 2 to 1 to 2. And that's what I would write down for my integrations for each of those peaks. So that's how you find it. Again, you'll have a different molecule, but that's the process, okay? The other thing is if you can't see what the splitting is, generally I just export everything and look at it from the PDF. But if you go back later and you can't figure out what it is, you can actually just redo the NMR. And if you just click it and highlight it, it'll zoom in. And then you can see the splitting a little bit better. So for this molecule, again, not your molecule, but there's a doublet here. That's clearly 2. And this one is a triplet. It's kind of crooked, but it's a triplet. It's got 1, 2, 3. And this one's also a triplet, 1, 2, 3. So if you look at that, that should only be 1 hydrogen. So it can only be 1 peak. That's how I know from the integration that's 1 hydrogen. So this has to be triplet. It can't be a doublet because it's crooked, too crooked to be a doublet. Okay. So does that kind of make sense? And then when you want to get out of this view, you can just zoom out. So whenever you have the PDF though, you just want to have it like regular and you'll be able to see the normal stuff. Okay. So I did click save for my NMR, and then I would go in the lab notebook, and then just like I would the IR, I'd just be like NMR of whatever it is. Mine is benzaldehyde. Yours is going to be something else. Okay. So that's the whole process for the NMR. So you're going to do that for ethanol, and then basically you're going to take the NMR of ethanol, then you're going to throw that away. And then you're going to do it for the benzoyl chloride and put it in the flask and drag it out. For that one, you want to take, it says you want to take the NMR here, right? It says take the NMR the same way you did before. And then it says you also want to take the IR. So just make sure that you get the IR of that. I didn't make you do it for ethanol because we've already done ethanol IR. We've seen that one. So I just didn't make you do that one because you get the idea of what that looks like. Okay. So then you're going to set up the reaction normal. Everything needs to be cleaned up first, so make sure you clear it out so you can get to the stuff. And then you're going to just do everything normal, take TLCs and stuff like that. The only thing that I noticed for this one is that you have to put in the benzoyl chloride first. If you put in the ethanol first, it like just doesn't go. And you can tell it's not going because if you do it and it takes more than like an hour, that's obviously too long for this reaction. And also it's going to be like nothing happens. Like you take the TLC, the starting material is the same spot as the product. That's not right. You should have like 2 spots on the right side or 1 if it's just the product, okay? So you should not have starting material only if it's actually working, okay? So you just do the normal reaction. At this one, you want to take a TLC at 1 minute. That tells you already this is probably a pretty short reaction. So again, if you go over an hour, that's like way too long, okay? So this is a short one, so that's good. And basically you can tell it's done by looking at the board on this side, and you're going to wait till something's gone. So we have more than one starting material, right? We have ethanol and benzoyl chloride. One of those is always going to be in excess. That's normal for a reaction. So if you look, I'm going to tell you which one to look for. So just look for the benzoyl chloride to be gone. Once that's gone, the ethanol is never going to go away. So just the benzoyl chloride, when that's gone, your reaction's done. Okay? And then you do the normal workup. You're going to say what's in the layers. You're going to do this. I, for some reason, accidentally wrote what's the name of the final product twice. Just fill it in twice. They're the same final product, but that's why it's there. Okay? And then make sure you export the file so that you have everything in the PDF and you don't have to count on Beyond Labs at like the last minute right before it's due. Okay, so just make sure you do that. These are all the information that you're going to have, but they're copied into the PostLab, so you can just find it there. And then the PostLab also has tables to put your data in. So this is like a blank table. Don't use this one. Use the one that's in the PostLab because it's a little bit more detailed. Okay, so that's all you have to do for Beyond Labz NMRs. So hopefully that was helpful, and I think we're ready. So you guys can get started. And stop recording.